DerekBLowe, The Chemistry Book, From Gunpowder to Graphene, 250 Milestones in the History of Chemistry. Delve into the magical world of chemistry with The Chemistry Book, From Gunpowder to Graphene, 250 Milestones in the History of Chemistry by DerekBLowe. This fascinating book explores mankind's scientific achievements from the Bronze Age to modern discoveries, touching upon significant advances in the field and their implications on our daily lives. Get ready to learn about the chemical reactions that shaped our history, the ancient chemists who pushed purification and refinement techniques, the role of chemistry in warfare, and how modern research methods have led to life-saving drugs and a cleaner environment.
The origins and evolution of Bronze and Iron Age. Chemical reactions have existed on our planet since ancient times, with the Cueva de los Cristales in Mexico being a remarkable example. Bronze represents a significant turning point in human chemical discoveries, with its discovery during the Bronze Age transforming societies. Human achievements in chemistry then transitioned from the Bronze to the Iron Age. Iron technology spread far and wide despite its labor-intensive process, and it's believed that locations as distant as India and sub-Saharan Africa developed the technology independently from each other. The advancements of ancient chemists. The earliest documented chemist, Tetraethyl, was a Babylonian woman who made perfume using a purification process involving distillation and filtration in 1200 BCE. Ancient chemists advanced purification and refinement techniques, often with hopes for gold and eternal life. The Egyptians used water to clear away debris and collect bits of gold until King Croesus of Lydia introduced a new technique for refining gold using a gold-silver alloy called electrum, but the exact methods remain unknown. The Han dynasty saw early use of mercury, with Qin Shi Huang using it in a misguided attempt at immortality despite its poisonous nature. Despite some dangers, ancient chemists made the most of what they had and contributed to significant technological advancements. The fascinating history of porcelain and alchemy. Discover the mysteries behind ancient techniques. Travel back in time to the Han dynasty around 200 AD, and discover the birth of true porcelain, an art that took centuries to perfect. This unique and beautiful ceramic required a secret mix of bone ash, alabaster or feldspar, ground glass, quartz, and kaolin clay, a special type of clay found in a village in southwest China that shared its name. But the precise recipe and its measurements remained a mystery, even as porcelain production surged over the years. Finally, in 1708, Johann Friedrich Böttger, an imprisoned alchemist in Dresden, and physicist, and philosopher, Ehrenfried Walther von Skirnhaus, cracked the code. They discovered that the secret was in the right combination of imported kaolin clay and alabaster mixed with water and fired at extremely high temperatures. Meanwhile, in 800 AD, across the world, scientific advancements were taking place in Islamic and Chinese cultures, led by Abu Musa Jabir ibn Hayyan, also known as Geber. He had a passion for alchemy in numerology, astrology, and medicine. Geber sought the philosopher's stone, an elixir believed to transform any metal into another form but remained elusive despite the efforts of many alchemists who followed in his footsteps. However, deciphering Geber's work remains a challenge, as many people wrote manuscripts using his name, many of which contained obscure symbols and coded language, leading to the word gibberish being coined. This book's summary takes us on an exciting journey of these ancient techniques, the significant contributions of scientists across cultures, and their enduring legacies. The unintended consequences of alchemy. While alchemists were on the quest for life-extending elixirs and turning iron into gold, gunpowder was accidentally discovered. This discovery, initially a military secret in China, led to a permanent change in the rules of warfare when it spread to other empires. The unintended consequences of alchemy also include advancements in toxicology and the discovery of ether, which became the first surgical anesthetic. This serves as a reminder that good and virtuous intentions can lead to unintended outcomes. The emergence of quinine and the birth of modern chemistry. In the 17th century, Jesuits introduced quinine, a medicine derived from the bark of South American cinchona trees, to Europe. Although initially used as a muscle relaxant, quinine was soon discovered to have extraordinary benefits in fighting malaria. The compound proved not only to be a game-changer in the field of medicine but also helped advance the field of organic chemistry. By the 1660s, Robert Boyle made predictions about atomic theory, which laid the foundation for modern chemistry, shifting away from alchemy towards a more scientific approach. With the Age of Enlightenment on the horizon, a new era of reason and science emerged, revolutionizing the world. The colorful history of Prussian blue. Prussian blue was accidentally discovered in the 18th century by German dye maker Johann Jacob Diesbach. The new blue pigment became popular in oil paints and was later named Berliner blue. The chemistry behind Prussian blue was finally understood over 250 years later, which led to the discovery of hydrogen cyanide and a drug to treat metal poisoning. This discovery also sparked a debate around vitalism, a belief that living things have something unique that non-living things lack. The Unlikely Innovator. Christian Friedrich Skonbein's seemingly accidental discoveries paved the way for some of the most significant scientific breakthroughs in history. Christian Friedrich Skonbein, a relatively unknown German chemist, made contributions to science that have paved the way for some of the most significant scientific breakthroughs in history. In many cases, landmark events required multiple discoveries, and Skonbein played a role in several of these events. In 1832, Skonbein accidentally discovered nitrocellulose, also known as guncotton. However, guncotton proved to be unpredictable and dangerous as a substitute for gunpowder. In 1847, Italian chemist Ascanio Sobrero decided to experiment with nitrating glycerin, which led to the creation of nitroglycerin. It was so dangerously explosive that Sobrero tried to keep the results under wraps for some time, but Alfred Nobel discovered it and became determined to stabilize it. This led to the creation of dynamite. Skonbein also discovered ozone in 1840. While conducting lab experiments that involved running an electrical current through water, Skonbein noticed an odd smell. He took the odor as signs of a new substance and named it ozone, which is a gas and a toxic one. However, its presence in the upper atmosphere is important and helpful. Ozone absorbs and protects life on the planet from the dangers of ultraviolet light. Ozone is also produced by lightning, like the electric current with which Skonbein was experimenting. Skonbein's seemingly accidental discoveries demonstrate that significant breakthroughs do not always result from planned experiments or remarkable knowledge. Discoveries, no matter how small or unintentional, often form the foundation for the essential knowledge that leads to scientific advancement. Dangerous but efficient chemical compounds. This summary explores the historical use of hazardous chemicals in chemistry, such as mercury, and how they are now replaced with less toxic alternatives. The focus is on how chemistry has evolved to be more efficient and safer with the example of mirrors and silver reaction. It also delves into how some dangerous substances like diazomethane can work wonders in chemistry despite their toxicity. Finally, it highlights the dangers of the MacArthur Forest process, which uses cyanide to extract gold from ore but is still being used due to its low cost and high demand. Despite being hazardous, these chemical compounds have played vital roles in the development of modern chemistry. The dark side of radioactivity. In the early 20th century, our understanding of radioactive substances grew, thanks to the work of scientists like Antoine Henri Becquerel, Marie and Pierre Curie, Ernest Rutherford, and Frederick Soddy. However, some discoveries, like the harmful effects of radiation, came at a heavy cost. Despite the danger, some entrepreneurs marketed radioactive products as beneficial, leading to tragic consequences, such as the death of Eben Byers from bone cancer caused by drinking radithor. This event led to new laws requiring product testing and approval before entering the market. The dark tale of tetraethyl lead. In the early 1920s, General Motors head Charles Kettering and chemist Thomas Midgley Jr. created tetraethyl lead, an additive that allowed gasoline to burn more evenly. Midgley swore that it was safe for human use, despite deaths occurring in the manufacturing of ethyl gasoline. It took decades before the detrimental effects of leaded gasoline were revealed, with American geological chemist Claire Cameron Patterson's research ultimately showing that the introduction of tetraethyl gas had quickly become the #1 contributor to lead contamination worldwide. This led to many countries banning lead from gasoline, paint, water pipes, and other products. The damaging effects of tetraethyl lead were not the end of the story for Midgley, who later became connected to another harmful invention, Freon. Chemical developments and consequences. The 20th century saw chemical developments creating serious consequences. Refrigerators with gases like propane, ammonia, and sulfur dioxide put people at risk. Freon was developed in 1930 to fix that. It was non-flammable and non-corrosive, but it was discovered over 40 years later that it was increasing the levels of chlorine-free radicals in the atmosphere. CFCs like Freon are reactive to UV light and cause a harmful cycle. One chlorine radical can destroy tens of thousands of ozone molecules. Frank Sherwood Rowland and Mario José Molina's study showed ozone depletion, and laws were passed to ban CFCs. The 1984 disaster in India's Bhopal, where 30 metric tons of mic leaked from a plant, covering 25 square miles and causing long-term lung and eye trauma, was a stark reminder of the disastrous consequences careless handling of chemicals could bring. The unending quest for life-saving medicines. Throughout history, humans have had an urge to derive healing and life-extending medicines from the remarkable variety of molecules on the planet. Modern research techniques have led to the development of life-saving drugs, pioneered by scientists such as Gertrude Bell Elion, George Herbert Hitchings, and Sir James White Black. Their innovative research techniques helped develop effective drugs to fight malaria, cancer, bacterial infections, and HIV/AIDS. Additionally, the combined forces of the drug company Merck and the bioengineering company Codexis cracked the long-standing goal of engineering enzymes, which has the potential to dramatically change not only medical chemistry but also the field of chemistry altogether. The future of drug development is exciting, with further game-changing consequences on the horizon. Innovations in chemistry. Chemistry's potential for a sustainable future lies in hydrogen and artificial photosynthesis. These innovations could contribute to reducing carbon dioxide emissions, making Earth inhabitable. Chemistry has always been a subject of interest, and it holds the potential to bring about a sustainable future. Hydrogen is a desirable and renewable fuel as it releases only water vapor when burned, making it an excellent alternative to our current fuels that contribute to the greenhouse effect. However, hydrogen storage is a significant issue to be addressed and could be resolved by 2025. Another innovation that could change the future of chemistry is artificial photosynthesis, estimated to arrive around 2030. Photosynthesis is a process that involves converting carbon dioxide and water into glucose, which is essential for plant growth. The process produces oxygen and regulates carbon dioxide, making Earth habitable. Samuel Goodnow Wildman's discovery of the Rubisco enzyme in 1947 opened up possibilities for improving photosynthesis. The enzyme is slow, and if scientists can enhance its speed, it could capture and remove more carbon dioxide from the atmosphere and reduce the growing climate crisis. Apart from benefiting the environment, artificial photosynthesis also has other advantages. It could help get hydrogen from water without using electricity, thereby reducing carbon dioxide emissions, one of the significant contributors to the climate crisis. With chemistry's potential for a sustainable future, hydrogen and artificial photosynthesis could be the game changers we need.
Throughout the ages, chemistry has shaped our lives in countless ways. From the Bronze Age discovery of better, stronger materials, to our modern advances in life-saving drugs and green energy alternatives, chemistry has played a vital role in human progress. Today, as we continue to tackle the challenges brought about by climate change, innovations in chemistry may hold the key to reducing carbon dioxide emissions and preserving the balance of our planet's ecosystem. As you journey through the milestones presented in the chemistry book, take a moment to appreciate the astounding richness of the history of chemistry, and how it continues to drive our ongoing pursuit of knowledge and a better world.